Hello and welcome to Lab 1, Charge Tapes. So the overall purpose of this lab was to understand how charge tape can interact with household items such as a book or a pen. Then it was also to calculate the excess charge on the tape by using Newton's laws and Coulomb's law. And then also it was to use Glowscript to visualize and interpret the data. As for the fundamental physics principles, there's two key ones in this lab being the gravitational principle and Coulomb's law. For the gravitational principle, it's just force times the acceleration due to gravity being 9.81 newtons per kilograms on Earth. For Coulomb's law, it would be Coulomb's constant times charge 1 times charge 2 over distance squared times the direction. Coulomb's constant would be 8.99 times 10 to the 9th. The magnitude of this force, though, does not require r hat due to it being the absolute value. And then for this lab, we will be considering it a point charge for both pieces, and this will also assume that the charges are equal, meaning that we can simplify it down to charge 1 squared. A quick preview of the results. The deficient electrons was found to be 4.19 times 10 to the 10th electrons. The tape ended up being positively charged with a charge of 6.71 times 10 to the negative 8th coulombs, and the total atoms found on the tape was 2.85 times 10 to the 17th. So these were the overall steps of the lab. The system for this lab was tape B, as you can see in the upper top right corner. The surroundings was tape A and the earth. And then some of the steps to set it up includes making sure that the tape is positively charged, as shown in the image in the bottom right, and the main data to collect was the final separation distance between the two pieces of tape. So the results from the lab concluded that the tape was positively charged after it was attracted to a negatively charged pen, and it also then repelled another positively charged piece of tape. The overall distance was about 18 centimeters, which converts to 0.018 meters. And then the dimensions of the tape were 0.19 meters by 0.015 meters. These were the overall calculations done in the lab. The main thing to conclude is that the sum of the forces was going to be equal to 0, and the two forces was gravity and the electric force, which means you could set them equal to each other. This led it to be, when everything was solved out, the charge of the tape was 6.71 times 10 to the negative 9th coulombs. The deficient electrons was 4.19 times 10 to the 10th electrons, and the ratio of deficient electrons to atoms was 1.496 times 10 to the negative 7th. So for the first model, it was a point charge model with tape B on top of tape A. So the force going up is the electric force as calculated in the function on the right, and the gravitational force being the force pulling it below. The charge of the tape ended up being calculated as 6.71 times 10 to the negative 9th coulombs. For the second model, being the line charge model, there was a magnitude of the electric force being calculated as 1.323 times 10 to the negative 4th, which makes about sense because when you consider that there's 10 of them, when you multiply that by 10, that's about approximately the same as the gravitational force. This left the estimated charge value to be 7.23 times 10 to the negative 9th coulombs. And in the bottom right, the code there is calculating each individual charge's electric force. As for the model prediction analysis, the positive charge in the tape led to an overall deficiency of electrons. This was shown in both models. Some of the potential errors was that the measurement of the distance could have been wrong, which could have led to the charge being calculated wrong. The point charge system was a little bit more oversimplified than the line model, which led to the line model having a higher value due to the distributed charges, and the humidity of the room could have affected it due to higher humidity would lead to less static buildup. Conclude lab 1 with the what ifs and why. If the charges were flipped signs, the observations would have been flipped. However, the second part of the lab would still be the same, since instead of being both positive charges, the two negative charges would still repel each other because similar charges repel each other. As for the why, which model would be better, the line charge model would be a better approximation due to the overall shape and geometry of the tape being reflected, and the distributed charges act as a better approximation for the forces.